Hello and welcome. Today we're going to explore a bit more of chapter 19, oscillation graphs. I am at O Physics, and the interactive that I've been now is oscillation graphs. So here we can test and play around a little bit on graphs and our knowledge of graphs. So if we look at our first graph here, we know that the velocity time graph, okay, is, let's start with the displacement time graph. Okay, so the displacement time graph, and we need to find its corresponding velocity time graph. So the velocity time graph is always a quarter behind the displacement. So this velocity time graph would start there. This means that this is the correct graph. Now, if we look at the next one, now we want the acceleration. So the acceleration is always 180 degrees out of phase. So if this goes up, the acceleration has to go down, and that would be our next one. Okay, so acceleration is opposite to this one. Okay, and now we're looking at the velocity and comparing it to the force, and the force is always the same as the acceleration. So if my velocity starts here, my acceleration is 90 degrees behind it, or a quarter wave behind it. So my acceleration would start there. Therefore, we will choose this one. Now, if I have a acceleration time graph and my velocity graph, then my velocity graph would start there. Displacement is opposite of acceleration. Displacement, the velocity must start a quarter behind it, so we're here, no, there, okay, and so forth. So just check something to note: the force is directly proportional to the same as the acceleration. There is one last thing also in terms of graphs. We know that a simple harmonic motion, the acceleration is directly proportional to the displacement, but in the opposite direction. So since we have that, if we draw a graph of acceleration and displacement, the graph would look like this. And we know that the equation actually looks like this when we turn it into an equal sign. So the gradient of this graph is then negative angular velocity squared.